Today, dear learners, educators, and seekers of understanding, welcome to Learning Academy Foundation by Mr. Andrea. Today, we embark on a journey not just through circuits and code, but through the very heart of modern civilization, the computer. This marvel of human ingenuity is more than a machine. It is a mirror of our minds, a servant of our creativity, and a tool for transformation. Computer literacy is a working understanding of computers and their uses. Which one is their purpose? We can have general purpose computers that can run any number of software applications and special purpose computers that are designed primarily for one particular function. At the core of every general purpose computer lies a beautiful partnership. Hardware, the physical components like the CPU, memory and storage, speakers, monitor, motherboard, power supply unit, mouse, USB, and so on. And the software, the instructions that tell the hardware what to do. Together, they form the general purpose computer model, capable of running countless applications from word processors to scientific simulations. So from the input, there is the CPU that receives data, and the CPU is made, central processing unit is made of control and arithmetic and logic unit. This changes data with internal and external memories. It can be ROM, read-only memory, or RAM, or RAM, random access memory. And then there is the output. So the central processing unit is the brain of the system. It carries out instructions, performs calculations, and orchestrates the flow of data. It's the conductor of the digital symphony. What is the von Neumann stored program computer? This computer is a serial machine. Data and instructions can be stored in the same memory location and acted upon sequentially. So from the processor, it addresses through system bus to the main memory and receives data and instruction. This model, proposed by John von Neumann, revolutionized computing. It introduced the idea that both data and instructions could be stored in the same memory. This led to fetch, decode, execute cycle. Fetch, the CPU retrieves an instruction from memory. Decode, it interprets what the instruction means. And execute, it performs the action, be it a calculation, a data transfer, or a decision. This cycle repeats billion of times per second, enabling everything from video calls to space exploration. Let's peek inside the CPU. We have control unit, the direct operations like a traffic controller, arithmetic and logic unit that performs math and logic, registers like memory address register and memory data register. They are tiny storage areas for quick access. Then cache, fast memory for frequently used data. Clock, electronic clock through clock pulses, keeps everything in sync. And then buses, address bus, data bus, and control bus, read and write. They are highways for data movement. Each part plays a vital role in dance of computation. Let's talk about memory and storage, how to hold the threads of thought. As we have said before, we have main memory that stores data for programs currently running. It's temporary, empty when power is turned off, and fast access to CPU. So is where active data lives, fast but temporary. And then read-only memory, that is a built-in computer memory containing data that normally can only be read, not written to. It contains the programming that allows your computer to be booted up, etc. Data not lost when the computer power is turned off, and it is sustained by a small long-life battery in your computer. So it holds permanent instructions like how to start the computer. And then we have secondary storage. They keep data long term. Common types include magnetic devices like magnetic hard drive and magnetic tape in desktops. They use spinning disks and magnetic fields. Optical devices like CD and DVDs. They use lasers to read and write data. Solid state drive devices like USB stick and SD cards. They use flash memory, fast and durable. And then we also have cloud storage, like Google Drive or OneDrive. They are remote servers accessed via internet. Choosing the right storage depends on speed, cost, durability, portability, and capacity. So please, in the comments below, you can, based on your research and knowledge, you can rank each type of storage device. 1 is best and 3 is least good. From 1 to 3. These rankings are in general. There are likely to be many individual devices that do not quite fit this pattern. So let me know in the comments about this rank for your own research and knowledge. Let's talk about embedded systems. There are our silent servants. Not all computers sit on desks. Embedded systems are built into devices, washing machines, traffic lights, medical equipment. They perform specific tasks with precision and reliability. What about the operating system? It is our invisible guide. An operating system is the master coordinator. It starts and to be emitted and ready, and then to schedule dispatch to running. If there is an interrupt or it's timeout, come back to ready. But if not, otherwise, there is an input, output, or event wait. Then when it's completed, go to be ready. And then to schedule dispatch, come back to running and exit when it is terminated. So operating system, what does operating system manage? File management, organizing and accessing data, process management through first come, first serve, and round robin and priority based. They are scheduling tasks using methods. For example, first come, first serve is simple and fair. Round robin is time slice multitasking, and priority based is urgent tasks where urgent tasks go first by priority. So first come, first serve is by far the simplest CPU scheduling algorithm. The process that requests a CPU first is allocated the CPU first. It's like a queue. The first one who comes will be the first one who will be served. So first in, first out. And then what else does the operating system manage? The hardware management, handling input and output devices, input like keyboard, output like printer, and allocating resources. And then user interface management through graphical user interface that is visual and intuitive, and the command line interface that is text-based and powerful, and other interfaces like touch, voice, gesture, each suited to different users. So for the user, it's easy to understand to the window, easy to access to the cloud, easy to use the Outlook, easy to monitor the Azure, easy to troubleshoot, easy to control. About the document management system can be done for search, OCR, workflow, version control, document retrieval, document archiving, and metadata. What is the utility software? They are our unsung heroes. They keep systems healthy. How? Managing files. For example, organizing and securing data. Repairing files, fixing corrupted data. Converting files, changing formats for compatibility. For example, using TIFF, PDF, JPG, GIF, BMP, and PNG. Data compression, saving space from original data to the compressor called encoder. The data is compressed, encoded, and then to the decompressor called decoder. The data is decompressed. All this to save space. And then data defragmentation, optimizing storage, and backing up that to protect against loss. Let's see which are the ways to back up your data. External hard drives regularly copy or schedule automatic backups of important files to an external hard drive or SSD for safekeeping. Backup software, invest in a reliable backup software that provides automated scheduled backups and incremental file updates. Network attached storage, set up a network attached storage device to store and access backups from multiple computers within a network. And built-in backup tools that take advantage of built-in backup features provided by the operating system, such as Windows Backup and Mac OS Time Machine. And then finally, antivirus and anti-spyware, guarding against threats. How to develop robust software and identify vulnerabilities. Robust software is reliable, secure, and user-friendly. Developers must test thoroughly, handle errors gracefully, and protect against vulnerabilities like malware, data breaches, and system crashes. Security is not just technical, it's ethical. It's about protecting people. So business, IT, security, ethics, and society work for privacy, against crime, for better working conditions, individuality, health, and employment. And now let's make a Christian reflection, talking about the wisdom in the machine. In Matthew 16:18, we can read, "And so I say to you, you are Peter, and upon this rock I will build my church, and the gates of the netherworld shall not prevail against it." As we marvel at the complexity of computers, let us remember the source of all wisdom. Proverbs 3:5 reminds us, "Trust in the Lord with all your heart, and lean not on your own understanding." And then in verse 6, it continues with, "In all your ways submit to him, and he will make your path straight." In John 16:13, we read, "But when he, the Spirit of truth, comes, he will guide you into all truth." Computers may process logic, but only the Spirit discerns truth. Let our learning be guided not just by knowledge, but by love, humility, and service. Join the journey with the Learning Academy Foundation. I want to tell you today about the 4 phases of a successful learner journey. Learning is not a case of a one-off training module. Instead, it is a continuous process. When designing a learner journey, it is important to take account of 4 key phases to ensure the training offered has the desired effect. First, starting point. This is the phase in which learners first come across the topic. It lays the foundation for the learning experience. Second, initial study phase. The focus here is on the conventional building up of knowledge and skills. This phase is traditionally very much the central focus of a learner journey. Third, application phase. This phase is key to enabling employees to use what they have learned in their everyday work. What support do they need in this? Fourth, consolidation phase. This phase is all about engaging and interacting with colleagues to drive the topic forward and continuously improve it. If this message inspired you, taught you something new, or sparked curiosity, please like, comment, share, and subscribe to the Learning Academy Foundation. Together we build bridges of understanding, nurture hearts and minds, and prepare the next generation to lead with wisdom and grace. Thank you, and may your code be clean, your memory abundant, and your purpose clear. See you in the next video. Bye!